Hello everyone, I'm Nex and welcome to our next lesson, Systems of Linear Equations. First, I'd like to apologize for the delay of this video. I didn't have time and I wasn't in the right mindset to make it, so it got delayed for a week. Hopefully we can keep up to the schedule from now on. And without further ado, let's start. So last time we learned what equations are, what inequalities are, how to solve them, what the solutions are, and so on. Today I will try to ease you into how to solve systems of said equations or inequalities. Well, first we'll have to know what a system of equations is. It's two or more equations that can work together. For instance, we have multiple equations that involve the same variables. That eventually means that if we have an X amount of variables, we need at least X amount of equations to solve for all. Or, shorter version, for each variable there has to be an equation. So if you have 3 variables, you need 3 equations. And if we have 2 variables, as we will have for most examples, we will need 2 equations or more. Solutions must satisfy all equations in the system. So if we have, for instance, 2 equations in the same system with variables x and y, once we get the possible values for x and y, if we put them in each equation, the equality in both must be correct. But I'll show you more in the examples and how to know that exactly. Before we see the types of the solutions, of course, we have to see how to start solving the equations, so it's going to be easier to determine the solutions. First, we have to get one variable and isolate it on one side, like we did with linear equations. But this time we will put the other variable on the other side and try to form it in a way so we get y, like y is some expression. That way, when we get to graphs, you will see how much easier this is, because this describes a sort of function, which we can draw on a graph, and that way the y value represents the line, and based on the x we put in, we get a certain value. This solving process is useful for any linear equation, and if we have only linear equations, of course, we get one of the 3 possible interactions between the lines that would be drawn on a graph. The first type is one solution. We get one solution when 2 or more lines, so this red and this blue line, intersect at one point, and exactly one point. This point is the solution. So the x value, which is 0 in this case, and y value, which is roughly 1.5, these are the solutions to these 2 equations, or the system of these 2 equations, to be more precise. No solutions, which we get when there are all lines that are parallel. So this is only true for linear, the parallel lines, because with higher orders we get curved lines and it's harder to determine the parallelity. However, it's still possible to know if they intersect or not. We would know if 2 lines are linear if we put the same x in both or all of the equations and get y that is equally apart. Basically take a random x value, plug it in this case in both equations, then take the y value of the equations, subtract the y value of the equation 1 from the y value of the equation 2, and repeat the same process for another one. So let's take x is 0 and x is 2. If we get these 2 y values, take the difference between them. This difference would be the same if we took x as 2 and took the difference between these 2 y values. And that's how we know that these are parallel, meaning that there is no solutions to this set of equations. And lastly, the infinite solutions is when all equations give us the same line. So if we graph them out, they overlap. How would we know? If we put in a random x in all of the equations, we would get the same y value in all of them. Now, we may not always run into equations with x, y, maybe even z variables. So how would we graph it? Well, in this lesson I will be using x and y and maybe z in some cases primarily. If I ever do use a, b and other letters and symbols, it will be because I replace a term or an expression with that variable to make it easier for you to see what we're doing, how to move around stuff, and how to see the patterns. Other than that, I'm gonna be focusing on x and y, so it's easier to start with the graphing afterwards. Now, how to solve systems of linear equations? We have a couple of different methods. The first one is solving by substitution. The steps of said process are: first, we solve one equation for one variable by isolating it. like I showed you before, we isolate y. Next, we replace that variable with the expression. So that expression we got at the start on the other side of the y value, you put that entire thing instead of the y value or that variable in the other equation. So now you have a giant mess from the first equation put in the place of the variable that you isolated at first in the second equation, and then solve for the second variable. This may be confusing, but when I go step by step, you'll see exactly what I mean. With the third step, by solving for second variable, we got rid of that set variable, and we have a value for it. And now we put the value of the second variable into the first. Oops, I misspelled something. I guess my English is not as good as my math is. But yes, this was supposed to say find. So we put the second variable in either of the equations, so back substitute, and we find the first variable. This sounds complex, don't worry. I'll solve an example just so you can see what I mean. Now, we have two equations. 3 plus y is 2x, and x plus y is 9. So let's solve for y in the first equation. I move 3 to the right, and we have this isolated y value. So we plug it in instead of this y value. So this would take a form of x plus, and now instead of y, we copy the right side of this equation, equals 9. Next up, we isolate x. So we can break the brackets because there's no multiplication. So we get x plus 2x minus 3 equals 9. Since we have minus 3 on the left, we add 3 on both sides. So we move it to the right. And then divide by 3, because when you add x and 2x together, we get 3x. So we would get 9 plus 3 is 12, divided by 3 is 4. Meaning that x is 4. And if we place it, so this value x is 4 into the first equation, we can place it in either of the equations, but this one is already simplified and in order with isolated variable like we like, as from the last lesson. So I color this orange so you can see what I'm doing. I copy it down, and instead of x, I put in 4. And now I just keep solving. We get 2 times 4 is 8, minus 3 is 5, which means y is 5. And we see that the solutions to these two equations are x is 4 and y is 5. Now let's plug them back in, so we get 3 plus 5 equals 2 times 4. And the second one is 4 plus 5 is 9. 8 is 8 and 9 is 9. So these are the solutions to this system of equations. Let's ease you into the graphing. We do in, I think, next lesson, or in 2 lessons. I've graphed both of these equations. So you see 3 plus y is 2x is red, it goes up, and the x plus y is 9 is the green one, and it goes down. They intersect in the point 4, 5. Since the first coordinate is 4, and the second one is 5, we know that the first one is x and the second one is y, so we just connect the values and we get x is 4 and y is 5. This is the correct solution to this system of equations. This is just a test you can do to see if you calculated it correctly. You won't always have a chance to graph it, but if you do, it's a nice way to test it. Even with more complex equations, when you have to find out for one value, and the equations are much more complex, you can just graph them out. And any intersection is where your correct value is. Although you deal more with inequalities later on, but don't worry, we'll get to that eventually. Now, for example, number 2. Here we already started with one variable isolated in the first equation, so we can just plug that into the second equation, and I'll color the original one with orange, so we see which equation we're working with, and what I put instead of x as pink. So I got something like this. When I put x value in here, this is this part of the equation. We get 2 times y minus 4, end of brackets, plus y equals 1. Now we just multiply both of these terms with 2. We get 2y minus 8 plus y equals 1. Now we add y's together, move 8 to the right. We get 9 on right, 3y on the left. We simplify by dividing with 3, and we get y is 3. And we just plug it into the first equation, where it's x is y minus 4, and we get x is 3 minus 4, x is minus 1. Now we get both of the solutions, and let's put them into both equations to see if we are correct. So we put 3 as y, minus 1 as x, we multiply and solve, minus 1 is minus 1, and minus 2 is minus 2, which means that this is correct. Now we just prove it with the graphs. I graph the first one as purple, the second one as black. They intersect as -1 and 3. Since I swapped the order, but x and y value are still correct, we know that we solved it correctly and we can move on. Now, let's try 3 equations with 3 variables, because this is a bit more common when you get further in maths and science and whatever. First, with my knowledge and everything, I can see that this can be solved in an easier way, and we will do it later on in the video. But first we have to solve it with substitution, so we know how substitution works. First, I will isolate x in the first equation. By moving y and z to the right, we get this as the value of x. Now, I put it into the second equation, so x minus y plus z equals 2. And let's solve for either of the variables, let's say y in this case. Let's break up the bracket and add everything together. 6 is 6, minus y is minus 2y, minus z plus z is 0. Okay, perfect. We can solve for y then. And 2 is 2. We move 6 to the right, we get minus 4, divide by minus 2, and we get y is 2. Here we were lucky that z cancelled out, so we don't have entire expressions as x is 6 minus y minus z, and y is 2 minus z or something. I think it would be pointless just pasting everything in and complicating it, so let's simplify further. So in this already simplified form, or let's just say isolated form, because it's not much more simple. In it, I will put the value of y, so as 2. We get 6 minus 2 minus z, so x is 4 minus z. And we have 2 simplified equations that we can paste in the third equation, where we only have z as the variable. So instead of x, we put 4 minus z. Instead of y, we put 2. And we get 2 times brackets of 4 minus z plus 2 minus z equals 3. Now we multiply the brackets, we solve, we move z's to the left, the numbers to the right. 8 plus 2 is 10, 3 minus 10 is minus 7, minus 2 minus 1 is minus 3. Now we just divide by minus 3, and we get z is 7/3. Now we have 2 variables solved, and we can put them back in the original equation, or we can just put the z in here. I'll do this, the latter one. So 4 minus 7/3. We multiply 4 by 3, so it's easier to work with fractions. We have 12/3 minus 7/3. We take the top part, 12 minus 7 is 5, so x is 5/3. Let's order the solutions and paste them into the equations to see if they're correct. So we put x, y, and z in the first equation, we get 5/3 plus 2 plus 7/3 equals 6. In the second equation, we get 5 divided by 3 minus 2 plus 7 divided by 3 is 2. And the third one, it's a bit more complicated with the multiplications, but we get 2 times 5/3 plus 2 minus 7/3 equals 3. Now, every fraction will be colored orange, so it's easier to work with them. I move numbers, so the white colored to the right, the fractions to the left. We get 12/3 equals 6 minus 2. We get 12/3 is 2 plus 2. And we get 3/3 is 3 minus 2. We get 4 is 4, 4 is 4, and 1 is 1. This is all correct. And this took us, like, what, 5 minutes? Well, it took me 10 minutes to record because I coughed and I had to drink and everything, but it took much less than it would take you because I know what I'm doing. I'm just clicking through the PowerPoint because I already set it ahead. But if you're writing this down, it will take a bit more time. After, we will learn a method that does this much faster. Now, to show you the graph, because we're working with 3 variables, 2D graphs would be very hard to do. So we use 1 dimension per variable. In this case, this is 3 dimensions. So you will probably never have to work with 3D graphs, but this is how one looks. Each equation represents a plane. Not, well, in 2D they represent a line. And technically they do. We just look at this edge. We don't see the depth of the graph, we just see one slice of it, so we see one line. With 3 dimensions, we extend it. And instead of looking for the intersection of 3 lines, we look at the intersection of 3 planes. And this is somewhere here, which is all positive, as we see x extends here, y extends here, z extends up, and we just drew a square around this. So it's inside the square, so all 3 coordinates are positive. Let's say that z is 7/3 is slightly more than 2, and if I rotated this graph, this is just a picture so I can, but if I put the graph in Desmos 3D graphs, you can do this on your own to see how it looks like. You can rotate it around and see that the z value is roughly 2.1, y value is exactly 2, and x value is almost 2. I do recommend it, Desmos 3D graphs, that's all you have to type in Google or whatever browser you're using. Get these equations in, and it will automatically graph them out for you. You can play around, you can have fun, but we won't be doing much of 3D graphing for now. Maybe in chemistry and physics lessons, but now we don't need to. Now, the second process is solving by elimination, which is a faster way. It's essentially just adding together or subtracting two equations, and it helps us get rid of an entire variable by doing so. So first, we align equations, so it's easier to see the variable that we're gonna eliminate. Multiply if needed to remove the variable. So if we have in one equation x and the other one 3x, we will multiply the x one with 3, so the coefficient is the same, and we can subtract them, so 3x minus 3x is 0, leaving us only with y. We solve the remaining equation, so left side is added to the left side and right side is added to the right side. We solve the equation, and we solve for the last remaining variable. Now, after we solve for the last remaining variable, we back substitute again by pasting it into either of the original two equations and solve for the variable that we cancelled out. This was even more confusing, I'm sure of it, so let's go to the example number 1. We have a simple example. 2x plus 3y is 8 and 4x minus 3y is 4. We see that we have 3y in both equations, one positive, one negative, so we will add the equations together like so. I colored each part of the equation, of both equations, with different colors, so it's easier to keep track. So if I'm adding them together, I will add the left side of the first one with the left side of the right one, sorry, the left side of the second one, equals to the right side of the first one, plus the right side of the second one, as you can see them colored. Now I color code them differently, so x variables are colored with blue, y are colored with red, and numbers are colored with white. And now I can just cancel the y's out, and we're left with 6x equals 12. We divide with 6 and we get x is 2. Now we place x in either of the equations. Let's take the first one, because it just seems much simpler, because we have 2 multiplied with it. We get 2 times 2 plus 3y is 8. We get 4 on the here, and we move it to the right, so we get 3y is 8 minus 4. Y is 4/3. Now we paste both of them back into the original equations to see if we're correct. 2 times 2 plus 3 times 4/3 equals 8, and 4 times 2 minus 3 times 4/3 equals 4. We solve. 4 plus 4 is 8, 8 minus 4 is 4. Now we graph them in. 2x plus 3y is 8 is the red one, and the 4x minus 3y is 4 is the blue one. We get an intersection, x is 2 and y is 4/3. The Desmos graph doesn't use fractions, the version that I use, so I will have decimal writings. If the decimal writings are a bit more complicated, I will also show you the rough version or estimation next to the fraction in the results, so it's easier to compare. But you can do it on your own as well, or you can check the actual result of this division. But yes, this graph shows that we solved this correctly. After the example number 2, here we have 2 equations, and we see that the y could be cancelled out with relative ease, but we have to multiply it by 2 first, because we can't just cancel out y's if one is greater than the other. The second equation gives us 4x minus 2y is 6. We put it here just so it's easier to compare. We add them together. We get 3x plus 4x, 2y minus 2y, and 16 plus 6. We add all together, so we get 7x and 22. We get x is 22/7. That doesn't roll off the tongue. Now, we put the result closer to the equations. We revert the equation to its original value, so it's easier to calculate the y because it's already in one value, so it's not multiplied by anything. We paste the x value in this equation, so we get 2 times 22/7 minus y is 3. We move y to the right. Well, sorry. First we solve the bracket out, so multiplication. Then we put 3 in the form of a fraction with 7 under the line, so we can move it to the left and move y to the right. And then we have a simple equation where we have 44 minus 21 is 23, 23 sevenths is y. These are the results, so let's graph them out. And we get this, which is the correct result. I put rough estimates here. I should use a different sign, but I couldn't find it. So just remember, when you're solving approximates, do not use just equals, because this is a hard equals. You can use two wavy lines. They actually look like this. You just put them together as an equal sign, and that's roughly, or just put a dot above it, so it's a rounded version. You can put these two values back in the equations to test, if you want to see that we did it correctly, but here is a graph that shows that we actually did solve correctly. Now, this example again, the same three equations we had before, we solve them in a faster way. Now, since with elimination we can add or subtract equations, here we can see that we could add the equation number 1 with number 2 to cancel out the y's, or number 2 and number 3 to cancel out the y's and z's, or we could add 1 to the 3 to cancel out the z's. There's plenty of different ways we can solve this, but I'll show you one step that will solve the most in the least amount of steps. So I will subtract the first two equations. As you can see, we can take x and z, they cancel each other out, and we're left with y minus minus y equals 6 minus 2. Minus minus equals to plus, so we have 2y is 4, y is 2. Simple. Now we add the second two equations because y's cancel out and z's cancel out. We add them together, we get 3x is 5, so x is 5/3, and we put it next to the results. Now we only need the z value, so we can plug the x and y into either of the equations. I will do it in the first one, so we don't have to needlessly multiply or subtract. And we order it around, so we take 6, subtract x and y from it, and we have z is 6 minus x minus y, which is 6 minus 5/3 minus 2. We put everything in the fraction, so it's easier to calculate. 18 minus 11 is 7, divided by 3 is 7/3, z is 7/3. Also, you may be wondering why I can just keep on solving. This is because this is an equation, so if I'm solving and putting these values in, this part is technically still equal to this part, which is still equal to this part, and this part is still equal to this part. So as long as this means this stays, so any individual part of the equal, a separate part of equal sign has to always be equal to any other part. So this has to be equal to any other expression separated by the equal sign, if that makes sense. This will be much more useful and seen in physics, where we work with an equation like for speed, which is distance divided by time, and you just keep on solving it. You can put other equations in instead of distance or instead of time, and so on and so on. Now we have the result again, and we can paste this back in, and we see that they are the same as we did it before. Much faster. I think this was like, what, 2 minutes? And if you did it on your own, there's also so little writing that you essentially save double the time. Now, system of inequalities, what is it? Well, it's a set of two or more inequalities in one or more variables. So this is a direct definition copied, so don't attack me for any inaccuracies. I just copied it from a source. I think I copied it from my math notebook, so it could be outdated by now. But yes, it essentially means that, just like with equations, we need equal number or less variables that there are inequalities for you to be able to solve them. And if you remember inequalities from our last lesson, we got intervals as results. And when graphed, the results were either an area or values on the number line in 1D that the inequality described. Now we have more than one inequality, which means there are gonna be overlappings in said areas, and we're gonna have to find a specific part that is overlapped by all of the inequalities. Now, since we hadn't learned graphing yet, I cannot really explain this because I have to assume that not all of you know graphing yet, so you'll have to do this on your own, which I do encourage, as my videos are not meant to be the sole textbook that you have to read from. No, they're more of an introductory guideline as to what certain topics are, maybe light the flame of interest in some, or just to give a small bite of the full meal, that you do have to look up the recipe so you can eat more of it if you want. Essentially, I'm introducing you to the topics, to the knowledge and the basics of it. You do have to study on your own, as hard as that sounds. My lessons are not enough. I may start a Patreon with mini tests or more tests so you can solve them and study that way more efficiently. But yes, all I can give you for solving system of inequalities is that you graph them out, shade the appropriate areas, find the overlap of these areas from all of the inequalities, mark that as the solution, as any point in the overlap has coordinates that, when put into either of the inequalities, will give you the correct results. For instance, like 0 equals 0 in equations. Now, I can also leave you some advice to remember when solving with graphing. If you do know how to graph and decide to practice on your own from many examples on the internet or in the books, I will leave you something to keep in mind when solving. Do not forget to flip the inequality sign when multiplying or dividing by a negative number. That is number one rule in every single inequality solution thingy, whatever you do. Next is marking the wrong area. So hopefully you still remember a bit about the 2D inequality graphs I did in my last video. You have to mark under or above the line. Sometimes when lines are almost vertical, it gets hard to know what's up and down or left or right on horizontal ones. In such cases, I suggest you take two random x values decently far apart. I suggest at least 10 units, but any distance is fine, even 1 and 2 are fine. As long as there are different values and you know which one is greater and which one is lower than. Put them in the inequality and get their respective y values. If the x value that is smaller has a y value that is bigger, then the greater x that has the smaller y, then the function is downward sloping, which is indicated when a negative factor is multiplied. I'll show you an example in just a bit. And when the y is smaller, so when everything is the opposite, it's an upward sloping function. So let's show you the example. Here is the negative coefficient, which means the function should be falling. And since this looks almost vertical, I could zoom out and show you that it actually does diverge from the line, but to a naked eye or just a like observer, this would seem vertical. And so if you have this as an inequality of, let's say, y is less than minus 100x, let's take two x values like minus 10 and 5. If we put them in the inequality of y is less than minus 100x, we would get that the y1, so from negative 10, is less than 1000. And for y2, which is from 5, so x is 5, we get y is less than minus 500. So we see that the greater x leads to a smaller y. This means that it has to be a downward sloping function, so we know that the left of the line is under it. Also, this coefficient tells us this, but if we don't have it given, we just have to assume. Although you should always have it given when solving the equation like such, if you have to know what's under and it's not very clear. But yes, let's show this inequality. We see that it actually is left, because it's a downward sloping function. Next, let's take another extreme case with inequality of y is greater than 100x, so upward sloping, it looks pretty much the same. Take the same x values, you can test it yourself. You get a smaller y and a bigger y, going from negative 10 that gives negative 1000 to 5 that gives 500. And we see that with greater x, y becomes bigger, upward sloping function, right of the line is under, so what's left is above. And since the y is greater than, the inequality tells us that the left side is the upper side. Next is mixing up solution regions. Sometimes, especially with more than two inequalities, you can get confused what areas are overlapped by all inequalities or if one or two are missing. So my suggestion would be just to use different colors for each inequality, or if you're just working with a pen or a pencil, use different types of lines, coloring them. So vertical filling for one, horizontal filling for the other, wavy for the third, sharp zigzag lines for the fourth, etc. So it's easier to determine which area, which segment has all of the inequalities in it. Next up is using the wrong type of line. So you have to be careful when using these symbols. So strictly greater than or lesser than means that you have to use the dashed or the dotted line, depends on what the teachers taught you. But when you have greater than or lesser than or equal to, so these two, you have to use the full line, like with equations. So these are the important rules you have to follow when solving linear inequalities. Hopefully you do solve them. Before I give you the mini test, of course the mini test is on the screen right now, but I do have to suggest that if you plan on studying, as harsh as that sounds, solving exercises, tests, anything, solving as many examples as possible, physics, chemistry, math, science especially, it will help you. You will understand concepts, when to use them, how to use them. So please use my videos as a guidance to look up the information yourself. I give you some key terms, some introductions. You can find much more on the internet. There's a lot of channels that do this much better than I do, more in depth, that have been doing this for years longer. So if you really are curious about wanting to know more, or if you're packing for the exam last study session or something, go on the internet, find more tests to solve. Just go ahead, solve as much as you can. If you get stuck on something, Google how to solve it. That is the best way to learn, especially math, when you have to solve a lot of things. Also, do comment down below if you see this. That's one thing I'm asking you to, please. No need to like or subscribe or anything. Do comment down below if I should make a Patreon on which I post dozens of tests, just like test after test after test, so you can just go there and actually have compiled exercises of the appropriate topics. I'm gonna also keyword them so it's easy to find whatever topics you need to study for the exams or whatever. But yes, comment down below, should I make a Patreon? If I get enough responses, if I get enough interest, I will do it. Thank you so much for tuning in to today's video. Good luck on the mini test and have a great rest of the weekend. See you on our next quest. Bye.